Hello, welcome back student to design and analysis of algorithm subject. Today we are going to study the knapsack problem. Before going to that, first we will see what we have learned the previous lecture. We saw the single source shortest path problem. The problem was like you need to reach from single source, okay, from one place to all the vertices which are present in the graph. Okay, so that is a single source shortest path problem, and we saw single source shortest path problem use the Dijkstra's algorithm. Okay, and this is use the greedy method approach. Next is today's is fractional knapsack problem, or we can say knapsack problem. Okay, this is one kind of problem, and this problem you can solve with the help of greedy method. And in the next unit you are going to see the 0 by 1 knapsack problem that we can solve with the dynamic programming. So this is a problem we can solve with the different approaches. Okay, till now we finish one approach, that is divide and conquer approach. Now we are seeing the greedy method approach. Okay, fine. So today we are going to see the knapsack problem. So here fractional knapsack problem or knapsack problem. Okay, so in this problem the objective to fill the knapsack with item to get maximum benefit, value or profit. Okay, you can use in your problem value or you can say profit without crossing the weight capacity in the knapsack, and we also allow to take an item in the fraction part. Example, take the example here it is telling to fill the capacity. Example, if some of the bag, take the example of bag, this is one bag, and in this the capacity is 10. Example, okay, the capacity is 10. So here you can fill, capacity is 10 and this 10 you can fill. So here the value and profit, so means in short this bag capacity is for 10 kg. Okay, so you can fill this bag, you should not exceed more than this bag capacity. Okay, so what is this? That should be less than m. I am considering this kg, whatever the bag capacity is there, that I am considering the m. Okay, and now in this we will have sigma x, here I and p. Example, I and p is like I is a weight and p is a profit. Okay, so you can write weight. Okay, you can take weight, profit should be less than m or equal. That means whatever the bag capacity is there, you can put in the bag equal or less than. Okay, so when we take the example, then you can easily understand this concept. So remember one thing, so as per the knapsack problem we will have one capacity, weight capacity like 10 kg or 20 kg, whatever may be. So based on that, you need to fill the item in the bag. Okay, so this is a point to remember to solve the problem. Okay, in this problem we have a knapsack that has a weight limit W. So here we are representing the weight W. Okay, there are item I1, I2 and so on. There are different items are there, in each having weight W1, W2, so on Wn, and some benefit, value or profit. You can use value or profit associate with the value 1, value 2, value n. Okay, so what are the things are there? Three things are there: item, okay, item number, and what is a weight, and what is a value or profit. Okay, our objective is to maximize the benefit such that the total weight inside the knapsack is at most W, and we are also allowed to take the item in the fraction. Okay, so here you will have one question like what is a fraction and all the things. I will tell you. So this is a problem, and assume that we have a weight maximum capacity. What is the maximum capacity? Is 16. Okay, maximum capacity is 16. Take it as kg example. Okay, our object to fill the knapsack with an item such a benefits or value or profit is maximum. Okay, three things are there. First one is item is represented as I1, I2 and I3. So how many items are there? N is equals to 6. N is equals to 6. 1, 2, 3, 4, 5, 6. 6 items I have. Okay, weight, value. So what is our this? Means W is equals to 16. Means you can consider like take it like W only. W is equals to 16. W is equals to 16. And item 1 has the weight is 6 and the value is 6. Okay, so this fraction means example. Take the real time example. That example is like if you go to the kirana shop. Okay, in the kirana shop you can buy the sugar. Okay, sugar you can buy. Sorry, sugar you can buy half kg, 1 kg, 2 kg, 3 kg, anything. Okay, like if you go to Pulse. Okay, if you go to Pulse also you can buy the fraction like half kg, 1 by 2, 1 by third. So you can buy like 250 gram, 300 gram, 1 kg. You can buy in fraction. Because of that we can use the fraction knapsack problem. We are telling this problem name is fraction knapsack problem. In the coming classes you are going to get the 0 by 1 knapsack problem. Okay, what is that means? Which item you cannot be make half, we cannot divide, that kind of problem is called 0 by 1 knapsack problem. That example is washing machine, fridge, you cannot make half. TV, you cannot make half, you need to take full. Either you need to take all, means you need to take fridge, otherwise no need to take. That is called 0 by 1, that you are going to get in the coming classes. Okay, now we are using the fraction. So take the example of kirana shop. Item 1, the weight is 6 kg okay, 6 kg example, and the value is 6, okay, and the item 2, the weight is 10 and the value is 2. Same thing, item 3 is weight is 3 and the value 1. Item 4, weight is 5 and value 8. Item 5 is weight is 1 and value is 3. Item 6, weight is 3, value is 5. Means this item, this many kg, and this is a price consider, okay. Now the question is, what is our question? We need to get the maximum value or maximum profit, okay. How we are going to get the maximum profit? So here, if you go down the next step, okay, we need to find, we cannot say which one, like which one is a maximum, which one should I take first. The question is, from this item, which item should I include first, okay. So for that reason, the step 1, we need to calculate value per weight for each item, okay. Like example, here 6 kg and the value is 6. So what is this? Okay, this 6 kg total price is 6 rupees example. So what is a calculation? 6 by 6 is 1. Get the 1. 1 kg is equals to 1 rupee. Okay, like that we need to solve the problems. We need to get the density. Sort the item as per the value density in the descending order. Take as much as possible not already taken in the knapsack. So these 3 steps are there we need to do. So the first one is, we need to divide this to take the calculation. Second one, we need to descending order, which one is the highest density means profit, we need to keep that, okay. And the last one is, if it is already taken, you no need to take the knapsack. So here, what is this? Compute density is value by weight. So what is this? How we are getting this? 6 by 6. Okay. Next, what is this? This is 2 by 10. This 2 by 10. Okay. Next is 1 by 3. We will get this answer. And next is value divided by weight. Value divided by weight. 8 divided by 5. Here 3 divided by 1. And this is 5 divided by 3. Okay. So this is, we got the density. Okay. So we finish this first option, calculate value per weight each item. So we got this. Next, what is the next one? We need to sort the density as per the descending order. Okay. So here, what is our density? 1, 2. Which one is the highest? This one is the highest. Okay. This one is the highest. So you need to keep descending order from the top. Okay. So here 3, 1, 1, 1, 0, 0. This. Okay. Same thing we rechange. Previously it was item 1, 2, 3, 4, 5, 6. According to the density, we are changing the item also. Okay. 5, 6, 4, 1, 3, 2. Okay. Why we change this? Because we need to get the more value, more profit. Okay, we need to get the more profit, value or profit. So here now we will pick item such that our benefit is maximum and total weight of the selected item is at most W. So now we draw another table to represent knapsack. Okay. So first we are descending order, we change it. So I5, check I5, weight I5 plus total weight less than or equal to W. Okay. So what is this weight I5? What is the weight I5 is 1 plus total weight. What is total weight? We don't have, because first is we are taking 1. So previously the total weight was 0, here 1 and here 0, and should be less than or equal to W. So what is W now here? Or W is 16. Or W is 16. So here we are checking the constraint, the condition. 1 plus 0 less than or equal to 16. Yes. Then we need to make in the table, this density table we are adding here. Okay. So what, how much is remaining now? How much is remaining now? Is 16 minus 1 equals to 15. The back capacity is 16 and we added 1. Now what is our back capacity is 15. So the same procedure we need to follow to the next one. In the next graph, okay, next table, weight 16, that is check I6. What is weight I6? Is 3. And what is the total weight? What we got previously, what the weight we got previously is 1. So total weight is 1 less than or equal to W, that is 16. 4 less than or equal to 16? Yes, true. So this row, this item also we are adding here. So what is total weight now? What is our total weight? Total weight 16 minus how much? 4 equals to 12. 12 is remaining. 12 is remaining. Now the same procedure applied to the next one, I4. I4 weight I4. What is the weight of I4? I4 is 5 plus total weight. What the total weight? We remove 4. So 4. 5 plus 4 less than or equal to 16. So 9 less than or equal to 16. Yes, true. Add this number here. Okay. Now 16 minus what is 9? 16 minus 9 equals to 7. Okay, answer is 7. That is 7 kg is remaining in our bag. Okay, next. In the same way, we are taking I5, I1. In the I1, what is the weight of I1 is 6 and the total weight is 9. Okay, total weight is 9. So 6 plus 9 is 15. 15 less than 16? Yes, true. And we are adding this here. Okay. Now what is 16 What is our total weight? 15 minus 15 is 1. Okay. So what is the capacity is remaining? The remaining capacity is 1. Go down. Here we need to check I3. I3, what is I3? The weight is 3 plus 15, okay, plus 15 less than or equal to 16. So here this condition is false because our back capacity is 16, but the total after adding this it is changing to 18. So how, what we can take now? Here to fill the bag we need 1. Okay, so this 3, the weight is 3, so we can divide it 1 by 3. Okay, I want 1, so 1 by 3. So when I do 1 by 3, the total value, the total profit is 0 by 0.33. Okay, 0.33. So when we get, like if you calculate this, okay, 1, 6, 7, 7 plus 5, 12, 12 plus 3, 15, 15 plus 1 is 16. Okay, how we can divide this? This item, okay, this item we are dividing into 3 parts. Clear? This item we are dividing into 3 parts, and this will be possible if we take the example of kirana shop, like sugar. If you want to take half kg, 1 kg, 1.5 kg, any item, that we can do the fraction. Okay, if we take the example of salt, if we want to take the example of pulses, okay, that is possible, which we can do fraction. That problem is validated. So here now, after this, is there anything remaining? 16 minus 16, because we are adding 1 here, so our weight is 16. So what is our back capacity now? Is 0. So rest of the items, like only 1 item is remaining here. This item we cannot include in the bag because we have the total weight inside the knapsack is 16. So we stop here. We are not including any other item. How many items are here that we are not adding here? Okay. So now after adding this, the main question is, you added with the help of weight, but what is the profit you are getting after adding this? This is a profit. Okay, if you do the total, okay, 5 plus 3 is 8, 8 plus 8, 16, 16 plus 6, 22, 22 plus 0.33 is 22.333. So this is our maximum benefit or maximum profit. So with the help of this knapsack problem, we can get the maximum profit. Here the 2 conditions are there, 2 things are there. First, we need to complete the constraint. Okay, what is our constraint? Weight should not more than the item and weight. Okay, the weight, the total weight should not, the total weight should be more than or equal to the items. I will repeat once again. Okay, so after taking the weight or profit, it should not be weight should not more than the bag capacity. So there are items. Once again I will repeat, knapsack problem is you can problem that is object to fill a knapsack with item to get maximum benefit or profit without crossing the weight capacity of knapsack, and we are also allowed to take the item in the fraction part. So we can allow the fraction part also. So there are item I1, I2 so on till IN, and each having weight and value is V. So our objective to find the maximum benefit such that the total weight inside the knapsack is at most W, and we are also allowed to take it in the fraction. Okay, so whatever the weight we have, we need to fill the bag till the end where we can fill, and based on that we need to get the profit. So this is a given problem. In the exam, this problem you will give like this numbers, item 1 weight value, you can take in the column way or in the horizontal way, as per your requirement you can take it. Okay, so this is a problem given by the here. This is a problem. What is the problem here? Here the item, weight and value. Okay, but we want the maximum profit. We need a maximum profit. So we directly we cannot take like this is 8 is a maximum, take it 8, 6, 5. We cannot take like this, because that will be, we need to check based on the weight. What is the density, means what is the profit we are getting. Okay, so for that the density. What is the density? The formula is compute density is equals to value by weight. Value by weight. When we do 6 by 6 is 1, then 2 by 10, then 1 by 3, then 8 by 5, then 3 by 1, then 5 by 3. So whatever the density, whatever the profit, okay, that we need to write here. So here in the value we are getting more profit or more profit or the more value. Okay, so in short we can consider like 1 we are getting the 3 profit, with the 5 when we sell the 5 we are getting 8 profit. Okay, that 8 we are dividing in the 5, then we are getting the each item profit. Okay, so when we get the each item profit, then we need to decrease write in the decreasing order, means highest profit, highest density should be in the top. Okay, so here the main concept for doing this is which one is a less weight, which one the less weight, we need to add that first, because we want to cover the maximum item in our bag. Okay, maximum item we want to cover in the bag, so we will get the more profit. Okay, so here we rotate like 3, 1.6, 1.6, 1, 0.3 and 0.2. This is a profit. So here we are adding, now we are checking the formula. With the help of formula is weight plus total less than 16. What is the weight now? Here in the weight I5 is weight 1 plus what is the total weight, because we are starting now, so we have not included anything in the bag, so it is 0 less than or equal to 16. So 1 less than or equal to 16 is correct. So we are adding that in the another box. Okay, so 16 minus 1 is equals to 15. When we added 1 here in the weight, so its remaining is 15. The same procedure we need to follow the next. Weight 16, 16. What is 16? Is the weight is 3 plus total weight. Total weight means what you have added previously. I added previously is 1. So that 1. 3 plus 1 less than or equal to 16. Okay. Then the total 4 less than or equal to 16 is true. We can add the whole value, whole weight in the bag. So we added here. Okay. Next, I4. I4 the weight is 5, and what is the total weight? Previously our total weight was 4. So 5 plus 4 less than or equal to 16. Yes, 9 less than or equal to 16 is true. So we are adding whole weight here. Okay. Next, we are doing the same thing, checking weight I1. What is weight I? Is 6 plus whatever the total weight we have added till now, 9. 6 plus 9 is total 15. 15 less than or equal to 16. Yes, true. We have added whole item, whatever the total item we are adding here. Next, I3. We are going to I3. I3 is total weight is 3, and the total weight, how much we have added? 15 we added. So 18 less than or equal to 16. This is not possible. Is not possible. So here what we need to do, because we need to fill the bag with the 1. So here we need to do the fraction 1 by 3. How much do you want? 1. And what is the weight? Is 3. 1 by 3 is, we will get the value 0.33. So the value of this we are taking here, fraction value. Okay, fraction profit. If we have 1, the profit is this. If we have 3, then our profit is 1. Okay, so the total weight is 16. Total weight is 16. And what is the benefit? What is the profit you are getting? You are getting is 22.333. Okay, so now in the next step, we don't have space in our bag to add some more items. So here we will stop, and this is our total answer. What is the answer? 22.333. This is the final answer. Okay, so this is important topic. Okay, and so this is a completed the answer. Okay, knapsack problem. The coming classes we are going to see the same knapsack problem with another method, that is dynamic programming and approach. Okay, so completed the fraction knapsack problem. Okay, summary is we completed. The next class we will see the another problem of the greedy method. Thank you very much. See you in the next class. Like and subscribe the channel.